All right. So we're going to talk about chapter 5, which is least squares regression. Okay. So we're going to talk about the regression line. Okay. Which is a straight line that describes how the response variable y changes as the explanatory x variable changes. Okay? Now, so it is the next step after you verify from your scatter plot that a straight line makes sense. Okay? So the idea here is you've got your x variable, your y variable, this is your explanatory, this is your response, this is also your independent, this is your dependent. We've got lots of names for them as you saw in the quiz today. Okay? So let's say that I've got something that looks like that. Okay? So does that look like linear regression might be a good idea? It does. Okay? So the question is, how do you draw the best line through those points? Okay? So I'm going to draw a line here. There's lots of different lines I could do. They might have slightly different slope. So the idea behind this is that we're going to use OLS regression. And I bet you're wondering what OLS stands for. It stands for ordinary least squares. Okay? So the idea here is, as I'm measuring my graph here, ordinary least squares regression minimizes the vertical distance from the points to the line. Okay? So as you look at here, the idea here is I'm going to minimize these distances here, the vertical distances. Now, there are other ways to measure these distances. I could do the horizontal distance, okay? I could do that distance there. Or I could do what we call the orthogonal distance, or you could think of it as a right angle. So if I make a right angle between all of these points here, I don't have any more points here, I'll put one in here, okay? Those are all right angles, okay? Now, the idea here is there's lots of different methods I could use. But we're going to concentrate on the OLS method, the ordinary least squares method, which minimizes your vertical distance, okay? That's the method that we're going to do. And I'm just going to say, I'm not going to explain it, but I'm going to say that it's the best method out there, okay? If you guys love statistics so much, who wants to sign up for my Math 2040 class? What? Thank you, Keaton. All right, so we'll talk about that in more detail there. But all I'm going to say basically is, trust me, this is the best method. Okay? All right. Now, how do you find the line? Okay? Turn this a little bit. You guys can make sure I'm on camera. Okay? How do I find the equation of the OLS regression line? Okay? So there's two formulas. You can think of your slope. Typically, we refer to the slope as m, right? M equals your correlation coefficient that we learned how to do last time times s sub y over s sub x. Okay? And then we're going to learn our y-intercept, which is b, and that's going to be y bar minus m times x bar. Okay? So once you found your m and your b, then you can say that y equals mx plus b. Okay? So we're going to use these two, plug them into this equation. Does that make sense? Okay?
What did you write, like your sentence? How do I
find the EQN for equations? You want me to write that out?
find the what?
Equation.
Oh, okay, okay.
A lot of times I will abbreviate that EQN for equation.
Oh, it's perfect.
Okay?
What's y bar?
What's y bar? Let's do an example, shall we? Okay? So for those of you who have computers, you can open this up. And for those of you who want to follow along at home, you can do that as well. Let's open up Canvas. I can't remember if I've uploaded it, but we're going to find out right now. All right, so class examples, is that in here? Nope, it's not. Okay, give me 1 second. I will upload this up here really quick. I'm going to create a new thing called worksheets. And I'm going to create one called Worksheet 4.1.
The S. Oh, the standard deviation of X and Y.
Okay. So, refresh your page and you should have a worksheet that looks like, oh, I'm going to get rid of this. I didn't think this one was, here, I'm going to erase all this stuff. Tell you what, here's what we're going to do. Well, erase all this stuff except for the data. Okay? All right, so let's talk about this. Okay? I'll have to upload. I thought I'd upload the one that wasn't filled in. Okay, a golfer has chosen to swing the ball on a 70-degree day with no wind. You want to see if there's a relationship between how fast you swing and how far the ball goes. I gotta make sure I'm sharing this. Am I sharing this? I'm not sharing it. Let's try that again. Okay? All right, so the first thing that you should do if you want to see if there's a relationship, before you do any regression, is you should do a scatter plot. So Olivia, do you remember how to do that?
Yeah, just select all of your data.
Select all of your data. Insert. Choose scatter plot right here. Boom. Is that a great scatter plot?
Did you just post these? What year?
Yeah.
How to put your access to
It's called Worksheet 4.1. Do you not see it?
worksheet 4.1.
I put a, there's, yeah, the one I uploaded there is not the right one, but it'll work. It's got a lot of the stuff there. Okay, what do I need to fix this? How do I fix this scatter plot so that it's a good one? I'll get all my points on the test.
Titles.
I need to put a title in here. What do you want to call it? golf swing on 70-degree day, no wind. Okay, what else? What'd you say?
Name the axis.
We need to add our axis titles. How do we do that?
Awesome.
Click the plus sign. Add the axis titles. What's this down here?
Yards. That one on the bottom.
Is this the yards down here?
On the bottom, swing speed.
This is swing speed. And what are we measuring our speed in? Miles per hour. And what is this? Distance in yards. Okay? All right, so, well, this would be good. So do we have time to do this? Did I show you the cheater method for finding the correlation last time? Briefly?
Let's do it again.
Okay.
I don't remember, so show us.
Do you want to do that?
If you did.
Okay. Trying to decide if I should do the cheater method or not. You guys probably need practice on this. Maybe we should do it the slow method.
Show us both.
Show us both. What's the cheater method for the correlation coefficient? Coral, okay?
Oh, I remember.
And then what's array 1? That's your x values, comma, array 2. So I've got to calculate a correlation coefficient of 0.938. We would call that what kind of correlation? Strong. Do you know how to do it by hand?
Let's do it by hand.
We'll do it by hand at the end of class if we have time, okay? I want to make sure we get chapter 5 going in here, okay? All right, so now we need to predict the line, okay? Now, these are the equations that I've got here. So I've got your slope. Here, can I make this a little bit smaller? Your slope, m equals r times s sub y divided by s sub x. And your b equals y bar minus m times x bar. Okay? All right, so we found our r here. Okay? We need to find our y bar, our x bar, our s sub y, and our s sub x. What do those all stand for? How's that? Can you move closer? That's what I should have said. Yeah. I love people who sit in the back of the room and then like, I can't see, and the room's empty. Okay? All right, so now what? What do I need to find out for this? The standard deviation, okay? How do I find the standard deviation? Okay, because I'm being nice this chest, right?
Yeah.
But on the final, you're going to have to do this by hand. Are you going to remember how to do it?
I will.
You will by then, okay? Didn't learn it for the last test, but we'll learn it for the final.
I didn't remember it.
Okay, standard deviation. Which one do I use? What'd you say? Sample. These are samples, right? This is certainly not every swing a golf club person has ever made, right? Okay, the standard deviation of the club's head speed is 2.29 miles per hour. And we're also going to need, in fact, I'm going to copy that. Standard deviation for the yards is about 7.74 yards. Okay, so now we can figure out our slope, right? So our slope is, can you give it to me, JC? Can you
Like
help
the
me?
equation?
Yeah.
Oh, yeah. It's y with the bar over it.
Oh, I thought we were figuring out the slope.
I don't know where.
Click the R.
Click the R, which is 0.938,
Oh, okay.
times, what's S sub Y?
2.9.
No, that's S sub X.
The other one.
What's your X and your Y? Okay, this is my X data, this is my Y data. Okay? All right, so we're going back here. So we're going to click on my R, which is
the 0.93.
93, okay, times
The y, which is the distance yards, which is 7.7.
7.74 divided by
The other one.
the other one.
2.29.
I don't think people know what other one is on the video, but yeah, 2.29. Okay? So I got a slope of 3.1661. Okay? Now, according to the other equation, what's y bar? What do you think y bar is?
The mean of y.
The mean of y. So I need to find my means as well, right? What's the command for the mean?
Equals average.
Equals average, and your curve still gates when you do that, right? Okay? So the mean speed, mean club head speed is 101.8 miles per hour. And the mean distance is about 266.75 yards. Okay? Does that make sense? All right, so now, Keaton.
What club are they using?
I can't hear you.
What club are they using?
I don't know. Which one do you want? They didn't tell me.
Probably like a 3-wood.
Probably a 3-wood, okay. Because, you know, your Tiger Woods, you can hit it way farther than that, right?
Makes a difference.
Okay, all right. But it was the same head. It was the same glove they used for all these swings. Okay? All right, so now, how do I figure this out, Gentry? What's my y-intercept?
Not 101.
So y bar, what's y bar? Is it 101?
That's the x one.
That's the x one.
So the
101 is
y
the
would
x
be
one.
the
The 266.75 minus, what's m?
Slow.
The slope, and the slope is
3. Oh, where is it? Right above.
It's right above it.
Thank you.
Okay, 3.1661 times
The x bar.
x bar, which is
The 101.
101. Okay? So I got negative 55.7966. So, Cray, now that I have those two values, I want to plug it into the y equals mx plus b equation, which is
That equals 3.166. X is variable.
x, you'll keep x as the variable,
Minus 55.79.
79661. Okay? Pretty cool. Can you do that on my test? Can you do that on my quiz on Thursday?
Is that the end? Or did you do
That's the answer. Yeah, this is what we're looking for. All those calculations to get
Can we
that.
do the quiz like on Excel?
Well, we got lots of computers in here, right? Oh, we actually, well,
Because didn't you say Thursday's in the thing?
Thursday will
on
be.
Excel or-
so you should be able to do this either on Excel or with your calculator. Okay, now here's what I will just mention here. Remember, if you're using your calculator, you can't use your cell phone. Okay? There are calculators out there that will figure out the standard deviation and the mean by hand, so that you don't have to figure it out. Okay? So if you only have a 4-function calculator and I give you raw data, you probably should know how to use your calculator to figure out the standard deviation without doing it by hand. Does that make sense? Okay? But on the quiz, more than likely, I'll probably give you this information and this information, and then say, can you figure out the equation for me? Can you do that? Especially if I give you those 5 numbers right there. Okay? All right. Now, let me ask you another question. Do you think Excel can do this?
Probably.
Probably. Okay? So here's how, so you can check yourself. How many points are you going to get if you only do it the Excel method?
100%.
0. Okay? But you can check yourself. Here's how you check yourself. Pick a point, any point will do. It doesn't matter which point you pick. Right-click on the point and then say add trend line. Okay, look at that. It adds a nice little dotted line there. And then you can say display the equation on the chart, and you can also display the R squared. Now, what do you think R squared is. It's not R squared, right? R squared is simply your correlation raised to the second power. Look at that. I got the same answer as Excel. I'm as smart as Excel.
What does that mean though? Like why?
What does that mean? That's a great question. Let's talk about what that means, okay? The correlation squared, the R squared. Let me stop sharing for a moment. Okay? Let's go back to the video here. All right. So, R squared sometimes is called the coefficient of variation. Okay? I can't remember if this book calls it that, but that's what it's called. Nobody that I know of calls it the coefficient of variation. They call it the R squared. But here's why it's a cool number. It tells you the percent of variation explained by the model. Okay? Now, in the example we just did, we got the equation. So the model, meaning the equation y equals mx plus b. So we got the equation y equals 3.1661x minus 55.797. Okay? And we got an R squared value equal to 0.8811. Okay? So here's what that means. Okay? That means that 88% of the variation. Now let's look back at our scatter plot for a second. Okay, so if we look at our scatter plot here, okay, then notice here, there's two times that we hit at 100 miles an hour. Okay, one time, the first time we hit at 100 miles an hour, and it went 257 yards. Another time we hit it 100 miles an hour and it went 263 yards, okay? So you can see one of those dots is above the line, one of them is below the line, okay? Now we can actually use the equation of this line to predict, okay? So if we use the equation of this line to predict, okay, what we're gonna do is we're gonna take our slope, 3.1661, we're going to multiply it by our x, 100 miles an hour, and then we're going to add my y-intercept, which is negative 55. So we would have predicted if I hit the ball 100 miles an hour, or excuse me, 100 miles an hour, it would have gone almost 261 yards. That's what the prediction would have been. So one time it went farther than we expected, one time it didn't go as far. So let me ask you this. Keaton, you look like a golfer, right?
Yeah.
You're a golfer. He's asking about, is it a 3-wood, a 5-wood, I don't know. Okay? So why would it go two different distances if you hit it with the same line?
Strike the ball better first.
Okay, so how you strike the ball, that would be one thing. What are some other things that might impact how far this ball goes?
The line, I guess that.
The line, okay. What else? Where you're hitting it?
Like in sand.
Oh, in the sand. Maybe the golf ball hit a little pebble and bounced backwards. Or maybe it hit a pebble and bounced forwards, right? What else might affect it? Yeah, we said there was no wind, but maybe there was a little puff of wind, right? That might have affected it.
Type of ball.
What'd you say?
This is the type of ball.
Type of ball, okay. So what we're saying here with this R squared value of 0.88, or 88, so 88% of the variation is explained by simply the swinging of the golf club. How much is unexplained? So 12%. So 12% could be how you hit the ball, maybe the ball type, maybe there was a puff of wind, maybe you hit a pebble. So there's reasons why. I mean, you can see two of these lines are right on there, but a lot of times there's some variation going on here. Okay, so R squared tells us that this is a pretty good model. 88% of the variation is explained by the model. 12% is unexplained. Does that make sense? Okay? Now, let me just say this. Stop sharing for a second. Okay, now according to this equation here, what if I hit the ball at 0 miles per hour? Okay, according to the equation, I would simply put a 0 in here, right? So that takes that out, right? So how far did the ball go if I hit it 0 miles per hour? It went backwards 55 yards. Right? Does that make sense? Okay. So here's the deal. Prediction outside the range is risky. Okay? And in fact, if I hit the ball 0 miles an hour, it doesn't make sense that it would go backwards 55 yards, right? So this model, as we look back at my chart here, at my thing, oh, I hate this. Okay, as we look back here, this is a really good model between 99 miles an hour and 105. Okay? What if I wanted to hit the ball 200 miles an hour? First of all, can anybody even do that? Not even Tiger can do that, right? Tiger won this weekend. First time in 5 years. What was the tournament? I don't even know. World Championship. Is he back? Is he going to be dominating? Okay. So the idea here is this works really good here, but it might not work. So if I hit it 50 miles an hour, it might not work very well. Because the problem is, let's say, for example, go back to here. Let's say, for example, here, I'm going to go back over here. Let's talk about the growth rate of a child. Okay? So if I put age and I put height, okay? If I did this, it probably looks very linear. Let's say between, say, 0 and 5 years, okay? But probably what happens, so I might be able to have a good y equals mx plus b equation here, okay? But the problem is people eventually stop growing, right? Okay? Well, if I picked somebody, and if I were using this as my data, and I picked somebody that was, say, 20 years old, they might be 9 feet tall. 9 feet tall, right? Because it works really well. Oh, I read this wrong. It works really well from 0 to 5, right? But it might not work very well because it might not keep going straight. Okay? So if you try to use, so this works really well between, say, 0 and 5, maybe even 6 or 7. But once you get too far out of here, you don't know what happens to the curve. It might curve. Okay? And I know the last time we talked about that crocodile, remember? How big was that crocodile head? It was 6 feet tall, the head. We predict if it followed regular crocodiles, it could have been 40 feet long. But it could have also curved, and we don't know. Okay? So we have to be a little bit careful when you predict outside the range. Okay? All right. What other notes do I have here? Oh, here's another thing. Let me add this on here, okay? So I'll just add some things that you should pay attention to when you're doing regression. Number 1, prediction outside the range is risky. Number 2, correlation and regression are strongly influenced by outliers. Okay, I think that we talked about this a little bit last time. You know, if I have some data that looks like this, and then I have an outlier here, what's going to happen is both with regression and correlation, this outlier is going to pull my line towards it. Okay, so then you'd have to say, should I include that point or not? Now, you might have something that looks like this. That could also be considered an outlier, and it might be okay to keep it in there. I had a teacher, she said that might be your Nobel Prize point. Okay? This might be your crocodile head that's 6 feet long. Okay? But you need to be careful. If you have an outlier like this, it might pull your line towards it. So then you're going to have to decide, in this case, should I include that point or should I not? It could be a typo. It could be legitimate. But if it's really far outside the range, it's going to affect your outlier there. Okay, a couple more things, and then we'll watch a video here really quickly. Correlation, as we talked about last time, does not imply causality. Okay? Does eating cheese have anything to do with the number of people getting entangled in their bed sheets? Okay, sure looked like it was correlated though, right? So, number 2, relationship between 2 variables can be influenced by lurking variables. We talked about that last time with polio, right? It looked like ice cream might cause polio. The lurking variable was, well, it's summertime and people swim. Okay? So a lot of times there's lurking variables. You can't assume that, for example, ice cream causes polio. There could be something else you're not considering. The best evidence comes from randomized experiments. Okay? The relationship may be due to direct cause, such as the polio virus. That would be a direct cause. B, it could be a common response. Or C, it could be simply confounding. Confounding, or I'll put lurking variables in there. Okay? And number 5, the relationship can be used for prediction, even if not a cause. Okay? All right. We're out of time for the Freakonomics. If we have time, I'll try to show you that next time in class. I think we have a lot of time going over the tests. So, quiz on Thursday will be in the library. We will try to go over, if we have time, we'll try to go over a correlation coefficient by hand. I'm going to try to post some questions for you to do on both regression and scatter plots. Okay? Yeah. You don't have to do it, it's just for practice. Yeah. But I will post another assignment for you to do. I'll post it in the announcement, so it's super clear. Okay?
So is there also other homework, or just what you're posting?
I'm going to try, I didn't get it up last time, but I'm going to try to get some good homework for both chapter 4 and 5, scatter plots and regression. Okay? All right, see you on Thursday.